So I think our next speaker is lucky that it's me announcing him, because there's not a terrible amount of people that can pronounce his name correctly. Next up is Gerrit Apeldoorn. I have a soft G as well, so probably not even the best. Anyway, Gerrit will be talking about Puppet and sort of like the bigger picture overview of how to put Puppet in your infrastructure. So, Gerrit, take it away.
Okay, thanks. So, I'm here to talk a bit about the manageable Puppet infrastructure. So, first of all, let me introduce myself. My name is Gerrit Apeldoorn. I'm a freelance Puppet consultant in the Netherlands. I pretty much only do really short-term stuff. So, companies hire me for a few days to help them get started, or if their code has grown organically, to help them fix it. So, also I'm the trainer for PuppetLabs Benelux. So, if you book a course in the Netherlands, you're stuck with me. So, first of all, a bit about the scope. I'm forced to talk a bit fast because the presentation is actually about 45 minutes. I managed to cut a few things away from it, but I'm a bit in a rush. On the internet you find a lot of talks and how-tos to how to configure a specific piece of the puzzle of a Puppet infrastructure. So, but never to how to configure the whole. So that's why when I decided to do this presentation, I also found out why, because it's very hard to get so many components and stuff and put it in a reasonable time frame to do a presentation about. So first of all, let's have a look at a few pitfalls that people, when they implement Puppet, fall over. So people, when they start to implement Puppet at a company, they're learning on the job. So when you start implementing, you really need to have some prior knowledge to make the right design decisions. So you'll probably end up with a hard to maintain code base and problems with collaboration, stuff like that. And you really have to refactor a lot to fix that, which is pretty hard once your servers are in production. So in this design, this kind of grew over a few years of Puppet consultancy. So I do a lot of really short-term stuff, and I found that this setup works for most companies. So let's have a look at the components that I'm using. This can be used for the enterprise version of Puppet as well as the open source. I'm using Hyra and Hyra YAML, which is a different backend. Mostly like YAML, only in this case you can encrypt individual values, which is very valuable, of course. I'm using Gerrit code review. So the code review part is not so much as to prevent faulty code to hit production. It's more about forcing everybody to look at each other's code. So if my colleague would hit a certain problem and uses a certain methodology to fix it, if I hit the same problem a week later, I'll probably use the same attack vector. So people start to code a bit more alike. Also, if I know that my code, everything that I commit, will be scrutinized by my colleagues, I might do a bit extra my best on it. So Gerrit is also acting as the Git server, and I'm using Git extension, Git-Flow, which is a great workflow, as Git is a very powerful tool. It's very flexible. It's very hard to align the way that people use Git for if multiple persons are included. So, lastly, I use R10K, which is a pretty cool environment deployment tool. It uses dynamic environments, and it also downloads all the modules from other resources. Other sources, I should say. So first up, I'm using server roles, which is a layer of abstraction. It's a bit similar to the crack-down roles and profiles methodology, only those are two levels of abstraction, and I find that a bit too complicated to work with. So this is much easier, and also easier to explain as well. So this is about creating a layer of classes, for instance, and not including the classes that do the actual work directly to the machines that you manage. For instance, if you have a role lamp here, The role lamp class includes Apache and MySQL, and in turn the Web01 and the Web02 will include the role lamp. So if I later on want to make a change to all of my LAMP servers, I can just change that class and it will be applied to all of my web servers in this case. So, and the same goes for different roles that you can create in your infrastructure. So how can we create such one? You just generate a module or create the directories manually, of course. I always create a role base, so that will be applied to all of my machines. And as you can see here, it includes some basic classes that I want set up the same for all my machines. Then for each role, I create a separate class in my role module, in this case role app, and in this case it includes Apache and Tomcat, and also you don't have to just include classes here. You can also specify a resource if you want to. And then after you've created them, you can include the role in your node definition in the site.pp. There's actually a smarter way to do this with Hira, and I'll show this later on. In this case, on the Apple1 server, the role base and the role app will be included. So this is about data, how we can extract data from our manifest. So we'll use Hira a lot, of course. And can I have a show of hand? Who is using Puppet but not Hira yet? That's quite a few. Okay, so you're gonna love this part because it's really, really powerful. Okay, so Hira is all about a hierarchy. So it has a pretty simple configuration file where you can use any vector fact to set up a hierarchy level. Usually you'll find client cert or FQDN at the top. I have found out the hard way that FQDN is not really reliable, because if you've got some funny stuff in your resolve.conf file, your server can be put in a different domain according to vector, which can hurt quite a bit. So client cert is the name that's on the certificate. So if your certificate has been generated with the right name, then this is really reliable. Also with the FQDN fact, if you put a custom fact in a module that has the FQDN as a name, you can override the existing one, which is a security risk, of course. So that's the top level, so we can put settings here for individual machines. The next one is environment in this case, so in which environment the Puppet run is done, and you can put any keys there. And lastly there's common, and as you can see, common is not a variable, it's taken literally, so there will be a common.yaml file. So given this as Hira data, if we have a node apple1.autoplan.com which is in environment testing, and we do this in our manifest, we have a Hira call, little earthquake there, and we look up this key, example key. So when we're at the Apple1, it will find it in the client cert.yaml file, and it will return that value. So if you have a different server, Apple2 for instance, that doesn't have that key in the most specific file, it will fall back to the testing.yaml if it's in the testing environment, and it will return that value. So that's how the hierarchy part works. Okay, so you can put different types of data in a Hira file, just regular values, key and a value. But you can also put arrays in here, the two different ways to write them up, single line or multi-line. And the indentation is important in this case. So also you should never use a tab in here, because you will get a very nice error message that doesn't point you in the right direction at all. So yeah, just make sure you just use spaces for indentation. You can also put hashes in there, so key value pairs in a hash. Or you can just mix them all together and make a large mess. So in this case we have the key 3 contains an array, and the key 4 contains another hash, so we can nest them as well. Okay, so a few functions that are related to Hira. We've seen this one before. It's the regular Hira call First parameter is the key that it needs to look up. You can also specify a default value. And so if the key cannot be found in Hira, it will return that value instead of providing an error message. And this hierarchy stuff with Hira is very convenient, because if we have something like this in our manifest, looks up the key smart host. For most of my machines, it will load this file, common.yaml, and provide the smart host that of our own company. For machines in the testing environment, we might send all of our mail to a different mail server to prevent our mailboxes from filling up. So machines that are in the testing environment will hit that one. And my own smart host should forward all its mail to the provider, of course. So there's the fully qualified domain name.yaml sends it to the provider. Okay, so we also have an Hira array, which returns an array. Only this does something specific. It doesn't stop at the first hit. It will go through all of the hierarchy levels and concatenate all the results. So in the case of when we're still at the app01 in the testing environment, this call will return an array of 5 values. So the 2 from these, 1 from this one, and the 2 from these. So these 5 values will be concatenated. If you do the same on the app02 server, which doesn't have the user key in its most specific file, it will return an array of only 3 users. So it also makes it very powerful to have some things that a value that applies to all of the machines, some on a specific machine. So that's very easy to use. Also, with Hira hash, does the same thing for hashes. So okay. Hira include also doesn't stop at the first hit. It goes through all of the levels, and only this one it includes every element of an array. So if we have this call in our site.pp and at node default, it will look up the key roles and include any element of an array that's returned from it. So in this case, the web01 will include role web and role base. So role base, as it is in common, will be included on all of my machines. So this is also a very nice function. With create resources, you can generate resource definitions. So for instance, we want to create, here's an example, we want to create resources of the type Apache vhost, that's the first parameter, and we load the data. It accepts the second parameter is a hash. We can also load it straight from Hira, of course. It looks up the key vhost. So if we look in our Hira data, this hash has 4 elements. So this will create 4 vhosts. And the next level down are the attributes of the defined type in this case. So you can use this for defined types, but also for regular types. So you can use this to create users or packages or files or whatever you want. And load all the data straight from Hira. So starting with Puppet 3, we've got data bindings. And this, if you have a class, a parameterized class, it can load the values of the parameters straight from Hira. So we can just include MySQL Server in our manifest. We don't have to specify the parameters there, because Puppet will load them straight from Hira. It will do so under a specific key. So that's a class name, : and the parameter name. So in this case we have MySQL : server, : and then the parameter name. And you can still make use of the hierarchies if you want to. So for instance, in the common.yaml, there's the most of my machines will have the password top secret. But for one machine, I want a different root password for MySQL, and it will be on the web01. It will be overridden, so my root password will be more secret. So if you put all of this together and look at the Puppet run, if we start a Puppet run, it will look at the site.pp. So we're not counting the ENC right now. Load the node default, and it will do a Hira include of roles. So this will look into Hira for the list of roles. In this case we have a role app listed. So it will go into my role module and load app.pp. That's over here, and this includes Tomcat. So at my Tomcat module it will load the class Tomcat, and it has a few parameters, Java Home and Java Ops. So it will look into Hira for the key Tomcat : Java Home, and it finds this value. So this value will be used as the class parameter. So, and using this, you can put everything, all the client-specific parts that are valid for one individual node, you can all load that from Hira. So this is deployment and workflow. I've got only 10 minutes left, so I'll have to rush a bit through it. First, a little bit about environments, which are very needed. They're pretty much nothing more than a separate module path and a site.pp. So usually you'll find development, testing, production, and they just point to different module paths. A node is configured to load a specific environment. This can be overridden in an ENC, so that a machine is forced to use a specific environment. Usually people don't use that. So you want different environments because you never ever want to edit any code in production, because that's very dangerous, of course. And the workflow with Git-Flow helps you to promote the code to production. So it's demo time. So I'm afraid I cannot do the full demo with due to the time constraints. So with Git-Flow you can, it's a workflow. You can create a separate, I forgot the term, a separate branch for a feature. Thank you. And work on that. Then you can submit it to the Gerrit server, and you can use that to make your colleague approve that code and put it merge it into the develop branch. So I've got a Gerrit server here. I'll go through the repositories real quick. I've got a main Puppet repository. I've got one for Hira. I've got one company-specific module where you can put wrapper classes and stuff like that. And I've got a role module. So I'll look at those real quickly. First of all, when using R10K, you can create dynamic environments. So if I'm working on a feature branch and I want to test it out, I can publish that branch, and R10K will create an environment for that. So what powers R10K is the Puppet file. I'll first do an ls. So this is my main Puppet repository, and the files that are important are the Puppet file and the site.pp. The modules, you'll see the directory here, but it's not part of the main Puppet repository because R10K loads a list of the modules that you require and will download them. So let's see. If I look at the Puppet file, you can see that this is a list of modules, and this it will download from the Forge, but you can also get modules from Git as well. So there's one module that I forked because it didn't do what I wanted, so I forked it on GitHub, and my role and Altiplan modules are custom, of course. So if I have a quick look at my roles module, a role can be pretty simple, like this one, role DB. It just includes Postgres in this case, or they can be rather complex, like my Django application server, which does a lot more and sets up some stuff. This one is interesting. This is create resources. It will load a class, a defined type that's in my company specific module, and that sets up everything that's needed for an individual Django application for my company. And it loads the data from Hira, as you can see here. So if we have a quick look at Hira, my Hira data, and I look at common.yaml, which is loaded for everything, we have a roles key. So in my site.pp there's a Hira include, and it looks up the key roles. And in the command.yaml, it loads the role base. And in my host-specific YAML file, I've assigned more roles, so you can put more roles and hook them to one machine. This is the data that's required for my planner application, and as you can see, eYAML has encrypted my password. So this is used by the create resources function, and if I use a specific alias that I've created that's using eYAML edit and puts in some keys as parameters, I can see that the password is decrypted for me and I can edit it right now. So, when I go to my company specific module, I've got a few things here. For instance, that Django application, this defined type sets up everything that's needed for that application. So it takes some parameters that are loaded from Hira and can set up pretty much anything. So this creates some users, put some supervisor stuff here, virtual environment, etc. So this is very specific. If you have an existing module and you want to add some resources to it, so for instance I'm using nginx, but I want to, in the defined type that creates a vhost, I wanted some extra stuff, I can create a wrapper defined type in this case, and I accept all the parameters that the original accepts, so that's quite a list, as you can see here, and I pass them on. And I can add some extra resources in here as well. So I wanted to understand that it's PHP stuff should be forwarded to FastCGI, create some directory and some caching stuff for Joomla. So this way I don't have to edit the original, but I can use the regular one and still have the path open to update. So R10K uses a central Git repository, and it will create an environment out of every branch that you've got there. So in my main Git repository I've got the development, testing, production, and it creates a separate directory for the module paths. Yeah. And it will check out each version that's in a branch of the Puppet file, and then loads all of the modules from the internet, from the Puppet Forge, or from Git repositories, whatever you want. So if you add another branch and run R10K, it will create another environment for you. And of course we need a separate repository for Hira as well. So a few final remarks. If you're using public modules, and you probably are, keep them as they are. Don't try to make your own version of everything, because then you cannot update them anymore, and which can be painful. You can create wrapper classes, of course, if you need some extra resources in a defined type or some specific things in a class. If it's really necessary, if it's broken, create a fork on GitHub. That's really easy, and you can add the Git repository in the Puppet file. And don't forget to put up a pull request for the original author, so the original will be updated. So, with everything that you do with Puppet, always try to anticipate future applications, and if something feels very complicated or fragile, there's probably a smarter way to do it, so research that. And don't forget to refactor in time, because if you see opportunities to make your infrastructure better and you postpone them, then you probably end up with a very complicated environment that's hard to manage. So, any questions? You have time?
One or two.
Okay. Yes.
Hey, so I'm in the process of refactoring my manifests. Moving stuff into Hira, but I'm worried that instead of complex manifests, I'm going to end up with complex catalog of YAML files.
Okay, so the refactoring of the code and moving data from the code to Hira, it is a concern that the Hira data is getting too complex. Well, of course, you should limit the number of hierarchy levels because it would be really difficult to find the correct value otherwise. But usually it's quite an easy path. You can just so for the other people, you can just enable Hira and move all of the variables out of there to Hira. But so usually it's it doesn't get that complicated. But so yeah, okay. So, yes.
What are your experiences using nesting data Hira? Like any bad things that you never tried to nest too much?
Well, not really performance-wise, but if you have a really huge nested Hira entry, then it's harder to break your classes down into little chunks because you have to load that specific piece of Hira data. So I usually try to avoid really huge structures because it makes it more difficult to break the Puppet code down into little chunks. So, does that help or?
I think so. If we're talking about kind of parameter structure.
Mm-hmm. Yeah.
I have a couple more.
You catch him offline, or online, but not here.
So the infrastructure that I've been using, it's all in a how-to on my blog. So and there's an email address there too. So feel free to ask.
All right. Thank you, Gerrit.
Thank you.